In this video, we are going to practice solving inequalities. Now, if you have solved an equality or an equation before, then most of the rules that we have with inequalities are exactly the same. However, there is one very important rule that you must remember. Rule: if you multiply or divide both sides of an inequality by a negative number, you must change the direction of the inequality sign. I'm going to give you a quick informal explanation of why this is true. Hopefully we all agree that 3 is less than 7. Let's go ahead and multiply both sides of this inequality by negative 1. And I'm going to put a question mark here. And let's decide, should that be a less than sign or a greater than sign after I multiply? Well, negative 1 times negative 3 is negative 3. And 7 times negative 1 is negative 7. Which number is bigger? Well, if you have two negative numbers like this, negative 3 is actually bigger than negative 7. So you can see that we had to switch the direction of our inequality sign. Notice if I multiplied by a positive number in this situation, like if I start with 3 is less than 7, and I multiply both sides by 2, I'll put a question mark here. 2 times 3 is 6. 7 times 2 is 14. In this case, 14 is greater, right? So here's an example, and this will always be true, but if we multiply both sides of an inequality by a positive number, then you do not need to switch the direction of our inequality sign. And in the first example, that is an example which will always be true, that if you multiply both sides by a negative number, you must switch the direction of the inequality sign. And the same goes here. We're multiplying. The same would be true if we are dividing, because multiplying and dividing are in essence the same thing. When we divide by a number, we're really multiplying by its reciprocal. So let's do a couple examples here just to make sure we understand this. All right, here we have 2x is less than 6. So for what values of x will 2 times that number be less than 6? Just like if we had an equal sign here, we want to get x by itself, which means we want to get rid of that 2. Since that 2 is multiplying x, remember 2x is the same as 2 times x, I'm going to divide by 2 to get rid of that 2. These cancel out, and we are left with x is less than, and 6 divided by 2 is 3. And notice we were dividing by a positive number, so I kept the less than sign as a less than sign. And this is our answer. We'll express our answer on a number line. I'm going to just put a 3 right here. And all the numbers less than 3 would be to the left. And we're going to put a curved bracket at the very end. All right, let's do the next problem. Here is slightly different. Now we have negative 2x is less than 6. All right. So just like before, we want to get rid of that negative 2. We're going to divide both sides by negative 2. These cancel out, and x will be, in this case, notice that we are dividing by a negative number. So we need to switch the less than sign to a greater than sign. 6 divided by negative 2 is negative 3. And so now our answer is x is greater than or equal to negative 3. So let's put our negative 3 down here. We're going to shade to the right. And again, since it's a greater than, not a greater than or equal to sign, we use a curved bracket. And by the way, I forgot to put the first answer in interval notation, so let's put both these in interval notation. One thing that helps me with interval notation, I like to put a negative infinity and a positive infinity on both sides, or past the arrows in my number line. And it makes it easier for me to see, for example, in the first one, okay, these are all the numbers in between. The smallest number would be negative infinity and 3. And in the right-hand side, it would be all the numbers in between. Negative 3 would be the smallest number, and infinity. So those are my final answers. One thing that you can do that might help you just make sure this makes sense, think about, okay, is 0, I'm going to just test 0 in both of these. 2 times 0 is indeed less than 6, so 0 would be somewhere over here, and that checks out, right? And you could check 1 or 2 or any number that's less than 3 and make sure that you get a correct answer, and you will see that that will be the case. 2 times 1 would be 2 is less than 6. That is correct. Over here, again, I could also choose the 0 should be a solution. If I plug in negative 2 times 0, that'll be 0. 0 is less than 6. That is correct. You could even try a number that's not inside of here and see, or that's not in our solution set. For example, I could do negative 10. This might be somewhere over here. Negative 2 times negative 10 would be equal to positive 20, which is greater than 6, not less than 6. And so we can see that indeed that is not in our solution set. Okay, let's do the next problem, which is number 3. 9 minus 4x is greater than negative 15. Again, here we have a variable term on the left-hand side, but not on the right-hand side. So I want to get the x on the left by itself. I'm going to move all the numbers to the right. I'm going to start by getting rid of that minus 9. Now, when I add or subtract to both sides of the equation, no matter what, whether it's positive or negative, it doesn't matter. I keep the inequality sign. Remember, the only time we switch the inequality is if we're multiplying or dividing, and only when we're multiplying or dividing by a negative number. These cancel out. I'm left with negative 4x, and make sure that negative sticks to the 4. And negative 15 minus 9 is negative 24. Here, I'm going to divide both sides by negative 4. And notice, whenever you multiply or divide both sides, always pause for a second. Am I multiplying or dividing by a negative number? In this case, the answer is yes. So I'm going to switch the greater than to a less than sign. The negative 4's cancel out, and I'm left with x is less than 6. Let's express our answer as on the number line. So less than 6 will be going to the left. And we are going to, since it's less than and not less than or equal to, we use a curved bracket going to the left. And again, and I'll put my negative infinity over here, in interval notation, that means my solution is all the numbers in between negative infinity and 6. And that is my final answer. And I'll just quickly circle my answers so that they are nice and clear. Okay, let's do number 4 next. All right, here we have an interesting situation where we have variable terms and number terms on both sides of the equation. There are many options for what you do first in this scenario. What I like to do is always get rid of the smaller variable term as my first step. The reason why is that helps me avoid negative numbers. So I'm going to get rid of the 3x since that is smaller than 6x, and I subtract 3x from both sides. When I put the minus 3x on the left-hand side, I make sure I put it underneath the like term, which is the 6x. These cancel out. I'm left with 3x plus 5 is greater than or equal to 2. So now my variable term is on the left, so I want to put all the numbers to the right. Next step, I'm going to subtract 5 from both sides to get rid of the 5 on the left. I'm left with 3x is greater than or equal to negative 3. And then I divide both sides by 3. Again, whenever you divide, pause for a second. Am I multiplying or dividing by a negative number? In this case, I am not. I'm dividing by a positive number, which means that my greater than or equal sign stays in the same direction. It stays a greater than or equal to sign. So this becomes x is greater than or equal to, and negative 3 divided by 3 is negative 1. All right, so let's express our answer. First as a number on the number line. So here's negative 1. And so I'm going to shade in, since x is greater than or equal to negative 1, I'm going to go to the right. I'm going to shade everything going to the right. And since it's a greater than or equal to, I use the square bracket. When I'm trying to express my answer in interval notation, I like to put I'll put positive infinity on the right, and then it becomes clear that this is all the numbers in between negative 1 and infinity. And that is my final answer. That is my solution set to that inequality. All right, let's go back and look at the next problem. The next problem is slightly more complicated. But the key to a more complicated problem is that it's not really more complicated. It's just going to be longer, but you do one step at a time, little by little, and you're going to get it correct. All right, let's start by here. Since we have parentheses, we need to do the distributive property to get rid of those parentheses first. So here's negative 3. I'm going to distribute that negative 3. Negative 3 times x is minus 3x. Negative 3 times positive 4 is negative 12. I'm going to bring down my less than sign. I'm going to distribute the 4. 4 times x is 4x. And then 4 times positive 3 is positive 12. Bring down the minus 14. Now here, before we do anything, there are some like terms that need to be combined. In particular, I need to combine these two like terms. So I'm going to do that next. I'm going to just bring down my negative 3x minus 12, bring down my less than, bring down 4x, and positive 12 minus 14 is negative 2, so I replace it with minus 2. And again here, now we look a lot like the beginning of this problem here, where we have one variable term on both sides of the inequality and one number term on both sides of the inequality. So just like I did before, what I'm going to do is I'm going to get rid of the smaller variable term. So I have two variable terms, negative 3x and 4x. I'm going to get rid of the minus 3x. So that means I'm going to do plus 3x to both sides to get rid of the minus 3x. I'm left with negative 12 is less than 7x minus 2. Now here, my variable term is on the right-hand side, so I want to send all the number terms to the left. So I'm first going to get rid of the minus 2 by adding 2 to both sides. I end up with negative 10 is less than 7x. And now I get rid of the 7 by dividing both sides by 7. Again, always pause here. And am I multiplying or dividing by a negative number? I am not. It is a positive number. And so what I'm left with is negative 10 over 7 is less than x. Now, I cannot simplify that fraction, but one thing I can do, this is a perfectly fine answer, but often we like to express our solution set with the x first. So I'm just going to do the mirror image of this, but you have to make sure if you flip the order, you need to flip the inequality as well. In other words, I mean, one way you can think of it is make sure when you flip things around, make sure the mouth of the inequality is opening towards the same thing. And notice in both cases, the mouth of the inequality is opening towards the variable x. All right, let's express our answer on a number line. So negative 10 over 7 would be about, we'll put right here. And we want all the numbers that are greater than, so we go to the right. And again, since it's greater than and not greater than or equal to, we use the curve bracket. And let's express this in interval notation. This will be in between negative 10 over 7 and positive infinity. And we are done. Here is my solution set expressed two different ways. All right, we've got one more example to go over, which is number 6, which is 3 times 4 minus 3x is greater than 6 minus 5x. Again, I'm going to do my distributive property. 3 times 4 is 12. 3 times negative 3x is negative 9x. Bring everything else down. Now, normally I get rid of the smaller variable term, which in this case would be negative 9x in this situation, because again, we have one variable term on both sides, one number term. Just to do a slightly different example, and just to show you it really doesn't matter which variable term or what you do in this situation, we'll get rid of the minus 5x first. So I'm going to get rid of the minus 5x, which means I have to add 5x to both sides of the equal sign. These cancel out, and I'm left with 12 minus 4x is greater than 6. So now my variable term is on the left-hand side, so I want to move all the numbers to the right. I'm going to get rid of my 12 first. These cancel out. I'm left with negative 4x is greater than negative 6. And now I'm going to divide by negative 4. Again, every time you divide, pause for a second. Am I multiplying or dividing by a negative number? I am dividing by a negative number in this case. So these negative 4s are going to cancel out, and I need to change the greater than sign to a less than sign. And this will be positive 6. Oh, remember, and if on the right-hand side, let's slow down for 1 second. If we have two negatives in a fraction, they really cancel each other out. This will be the same as 6 over 4. But I can simplify this because the numerator and the denominator are both divisible by 2. And so I get the final answer, which is x is less than 3/2. Let's express this answer, and that can't be simplified any further. Let's express this answer two different ways. First, on the number line, this will be 3/2, and we're going less than. So that'll be to the left. And again, since it's less than, so I lost something here, but that's okay. We'll use our curved bracket. And in interval notation, remember, notice that these are all the numbers in between -infinity and 3/2. And we are done. So, that was definitely a lot of examples. Hopefully that was helpful though. And we will see you in the next video. Bye.